There we go.
I was like, I sure hope somebody knows how to record this, because
Yeah.
Crystal's class on point the last couple times. So,
Well, my other class, we have to do this too.
oh yeah,
And they're like both native from China.
oh nice.
And they were like so confused. And it took us an hour to get it to work and like pull up. And then plus I was having like computer issues. And so it was just like a nightmare. But now I know what I'm doing. So,
Yeah,
okay, let's see. We have to open up some Excels.
yeah. For some reason, my computer's like toast.
Oh, that's not good.
Yeah,
Let me guess, you have a Mac?
yeah, and it's old.
Well, there's your problem. It's a Mac.
Yeah,
I just got rid of my Apple phone and switched to Android.
yeah. Did you get your messages to come through?
Oh. Yeah. I only have ever had a smartphone that's Apple, and so I'm like just
Yeah,
slightly frustrated because I don't understand how to work it. But
right.
other than that, it's been 10 times better. But
Yeah.
I like told my husband, I was like, "Where's the instruction manual? I don't know how to do this." Okay. You want to go ahead and we'll just start it and
Yeah, that's fine.
so the first question is, in an ANOVA hypothesis test, we reject the null when there is sufficient evidence to indicate at least one mean is different from the others. So I know that the null is that they're all the same and that the alternative is that at least one mean is different. So I'm guessing that's true.
Yeah.
I think like that's like the only difference. Finding the t-score and everything else is like the same. It's just
Yeah.
the hypothesis. Okay, what requirements need to be checked? Huh?
Sorry, go ahead. I was just reading it too.
Oh, okay. You know, you're fine. I know. Actually,
Pulling up,
don't know.
pulling up the reading. I think it's data in each group are normally distributed, and variances are equal in each group. Let me look at this real quick.
Okay. And I know that the variances one is true, but are they trying to say that like it has to be like the same in each? Like there has to be like 20. The do you know what I'm trying to say?
Yeah.
Because I'm struggling. Okay. Because I know like in the last lesson we learned that you can have like 10 numbers in one of the columns and like 50 in the other and still compute it. Is that what
Yeah.
they're saying? It has to be like the same amount in each group, or is it different?
That's what I'm. Hmm. I don't know. That's a good question there. Then in that case, then it wouldn't be, right? Let's see
I'm
here.
not sure. I guess I just found in the reading it's 3.2, the requirements, and it's that the data is normally distributed and that the variances are equal. So you were right.
Yeah, there it is. I love when it's like written word for word in there. It's
Yeah.
lovely. All right. To check if each group is normally distributed, do the following. That would be a Q and Q test.
Yeah. The Q plot.
Yeah, sorry. Construct a
No, you're fine.
Q plot for each group. We assume the variance in each group is the same if the following happens. Sample variance for each group is smaller than the sample mean. No. The largest variance is
It's
less
if
than
it's less than four
4 times.
times.
Yeah. So B on that one. ANOVA hypothesis test is equivalent to conducting independent two-sample tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there's 4 samples? So just be double that. So 6.
6.
Right?
4. 4 and 3. Yeah.
Ooh, soccer shoes. This is fun.
I like soccer, but there's way better shoes out there than just soccer shoes.
Oh, yeah.
Why aren't you opening?
Sorry, I gotta grab my charger real quick.
No, you're fine. There we go. Oops.
It was just playing last night. I was wondering what that beeping was. I was like, is that mine?
Are you talking to me?
Yeah. Is that not you?
Am I beeping?
I thought you were.
Maybe it's Will. Are
Yep.
you making beeping noises?
Sorry, guys. Hi.
We're done.
Hi, you're fine. We just.
No, I'm just kidding. We're just kidding. Yeah, it's your phone. It's like doing some weird echo thing.
Sounds like a little cricket.
I had a really bad echo last time. It was horrible.
I know whenever I try and like talk and explain something, I'd have to like plug my ears or turn my volume off because I get distracted hearing myself.
Yeah.
Ah!
Long day, Will?
Oh my gosh. Yeah. I have like a workshop for some stuff for my schooling in the middle of the day. So I did a split shift at work. So I worked like 6 a.m. to 9 a.m. and then went back at like 4 till 9. So yeah, absolutely a horrible day. But
When you're up till late doing a group meeting.
yes,
But this is the fun part of the day.
that's right.
Group meetings what I live for. You know?
I pulled a nice little 12-hour shift as well.
Oh my gosh.
But
Yeah, I worked 4 hours today. It was brutal.
yeah, that's insane.
Hey,
Yeah. I almost didn't make it. I had to stop and get lunch in between.
I'll bet.
Yeah.
Yeah, it sounds like somebody's fire alarm's going off. Everybody okay?
I'm good.
I don't even hear the beeping anymore, so go get a Q-tip or something. I don't know.
Yeah, I'm not hearing anything. Was it as soon as I joined or before that?
I don't know. I was away getting my charger. So.
It was like 5 seconds before your face popped up, Will. He like comes in the room and is like, I wonder where that beeper was coming from. It's like, what are you like? Who are you talking to? Like,
Oh,
is someone
funny.
there? Is someone beeping at you? Like, so I don't know if it was you coming into the chat room or what.
oh boy.
Huh.
All right, 18 questions.
Yeah, we're on number 8. We can catch you up real quick.
Okay.
Yeah. The other ones are like super
one
simple.
1 and 2 is false.
No, stop it.
Just kidding.
Oh, I thought you were talking about like question 3, and I was like, don't give it. What? It's true.
I was
Yeah.
saying like.
Okay, true.
Yeah, true on the 3. 4 is data in each group and variances are equal.
Right.
5 is QQ plot.
Okay, that's right.
6's largest variance is less than 4 times.
Largest. Okay.
If you don't if you don't agree with any of these, let us know as well.
Nope, I agree. That sounds great.
And then 7, we put 6.
Let's see. Okay. Cool.
So we were just getting to this.
So now we're on
number
opening
8.
up.
Yeah, we're just
Opening up soccer shoes, right?
Yeah.
Yeah. So really quick. So in this Excel thing, there's 5 types that I'm looking at. There's like the A, B, C, D, E, and then there's also socks.
Yes.
And they want us to go through and look at like which is like the biggest or like the smallest variables. Are we supposed to like input that into like one of like the quantitative Excel things? And if so, are we supposed to like do a 2 and 2 sample for each?
We pull up the quantitative inference procedures, and then you're gonna pull up the ANOVA tab, if that's how you say it.
Okay. Because I saw that link in the book, but I hadn't like clicked on it yet, and I was like, I don't know. Procedures.
And then like like footwear A, you'll copy over and put into, one of the columns.
Okay.
And you'll do that for each of them. And I'm pretty sure, because this is the same one from the readings, that you even do that for socks, because they mentioned at some point that they like let people just wear socks for one of the tests as well.
Yeah. Okay.
Okay.
Perfect. Why aren't you opening?
I could say the same thing.
There we go. There we go. I can hear him clicking and dragging. I know he's copying and pasting, and I don't even have the Excel thing open. Like giving me anxiety over here.
I'm sorry. Don't mind.
No, you're fine. No, now's not a good time to freeze.
All right, hold on just a second. I'll be back.
Okay. Buys me some time.
What's that?
There we go. Like, I'll be right back. I gotta go get something. It's like, that's fine. That buys me time, like, to try and get this done for you.
There,
Okay, there we go. ANOVA.
Okay.
Okay, so they don't have to have the same number of variables in each one.
No, I don't think they do necessarily, because it's independent data.
Yeah, gotcha. It's just like a random question I had a few minutes ago.
What is?
Ooh.
Oh,
that was just a random. Yeah.
Right. What is the?
Boy, alrighty.
And we have a test. Is it this weekend? Because we have that study quiz.
Yeah, not looking forward to that.
Yeah.
But we get for our test, don't we get one cheat sheet or something?
The cheat sheet, yeah, I think so.
See, mine last time was like terrible. I put like all the wrong information.
I think that like the best thing to do would be to copy over all the information in the like summaries at the bottom of the lessons.
Yeah.
You know what I'm saying? And I noticed that in the chapter that we're supposed to read for lesson lesson 14 or lesson 15, you can click on like show summaries, and it pops up the summaries for all the lessons for these. So
that's convenient.
Sorry, Quick question.
Yeah.
What is that that Excel template called?
The one that
It's
we
the same
put
one that,
we
yeah.
put the data into? Is that what you're
Yeah.
talking?
Yeah.
Quantitative inference procedures.
It's the same one that we've been using that has like the 1 sample T, pair sample T, 2 sample.
Yeah.
Yeah, I'm using a different laptop, so I gotta hurry and find it again.
Oh yeah.
And then we're supposed to find which one has the smallest variance, right?
Yeah, and I've got 27.208.
Perfect.
And then I believe the answer to 10 would be true.
And then the largest. And then for the largest, you got 53.158.
Did it ask us for the largest?
My number 9 does. My number 8 says the
Oops.
smallest, and my number 9 says the...
I'm glad you pointed that out because I put the same thing twice.
Oh, shoot. I mean, you're welcome.
What did you have? 53.158?
Yeah.
Okay.
Did you get it pulled up, Corey?
Yeah, I'm just getting it copied over, making
Okay.
sure that you guys are right.
That's right.
Yeah, okay.
Yeah, okay.
Andy, I forget what's the easiest. How do you do a QQ plot?
Oh gosh. Okay. So the way that I was doing it is there is an Excel sheet that he gave us in like the second chapter that like we read. And you just copy and paste the numbers into it and it pulls up a Q plot for you.
That's right.
Yeah. I haven't made one in like a couple chapters because it'll just like say like with like the prep assignments like, oh yeah, and then prove it with a Q plot. And I'm just like, well, I don't want to open that Excel sheet and I know how it works, so just skip.
QQ plots. I see it. Okay.
Yeah.
I see.
And then so for 11, they just want us to know if the dots are all on the line, and so it's normal.
Each sample based on what you see. Yeah, I guess they want us to do it for each of them.
Oh gosh.
Oh joy.
I'm just putting true. Let's be honest. And then you put true for number 10, right?
Sorry, 1 second.
No, you're fine. You just said it earlier, and I just wanted to make sure.
Looks good. For 10, yes, I put true.
Okay. What the heck? We've never like had to know how to do SPSS if we have Excel.
I don't think we actually have to.
Okay. You can just go ahead and look at the p-value in the Excel sheet.
Yeah.
I was like, I'm not doing that.
Yeah, I've got 0.0809, which, yep, round up to 0.081.
Yeah. 0.081.
So then,
Are you with us where we're at, Corey, or?
Yeah, I'm still trying to get this over.
no worries.
0.081.
Andy, for number 12, did you get 0.309?
I heard Andy for like number 309.
For number 12,
Oh, okay.
we're supposed to remove the column with the socks data.
Tomato. And then you got 0.309.
Yes.
And that's the number we're supposed to put in, right?
Yeah, I think that's what they asked, right? What was the p-value? Yep.
Well, thanks for saying something, because I completely put in the other number and like didn't even think about it. The T statistic is an F statistic, p-value to the area, right or left.
I'm pretty sure it's right.
Well, yeah, if it's positive.
Quick question for you.
Yeah.
Yeah.
What variable did you guys get being the smallest?
For
it was question 8.
Okay, so the smallest we had 27.208, which was number 3.
Yep.
And the data that you inputted, was it all 36? Or did I mess something up?
Oh.
So, are you on the ANOVA tab?
Yeah.
Okay, and you copied just the ones that have A next to it. Should just be like 10 into variable 3.
Right.
And the ones that have a B next to it in variable 2.
So I think,
right?
let me open this up again. I wonder if I messed it up, because I'm coming up with something else. I think I might have done a little something.
So the variable.
Oh yeah, I messed it up. I'm using a new Mac here, so I'm trying to. For some reason, all of my C data was 36s.
Okay.
So that's why. Let me get this in there. All right, cool. Yeah, we're good. And then 53.158 on the largest.
Yeah, is the largest. And then
True.
And then if you go ahead and quickly delete the last variable of socks, it should give you the p-value of 0.309.
Yep, that's what we got here.
Perfect. And then 13, we are just discussing, we think it's the right side.
It is. I looked it up.
You looked it up and that's what it says?
Yeah.
Excuse me, we don't think we know. Okay. Woohoo, new data. DASL. Then copy and paste a bunch. Oh, hold on, are we supposed to do? Okay, so we're doing the calories first.
Yeah, but it looks like they want us to do the QQ plots for them.
Project. Meat, poultry. Okay.
Nobody else hear that?
I just heard it, but it's
I
not
was gonna say,
too
sounds
loud.
like somebody's running their vacuum cleaner or something.
I don't hear anything. My husband has his laptop fan on, but it's on the other side of the room and it's super faint.
It's
That's
probably
one thing I
because I
can.
got like 5 electronic devices going on right now.
Yeah. Okay. So let me get this straight. We're supposed to compare variances, and to know if the assumptions to use it have met means that there has to be at least a variance of 4 in between them.
I think it's that the smallest variance, so that the greatest. Let's see, what was it? I think it's that the greatest variance is no more than 4
times
times the smallest isn't. I think that's what it is.
Okay.
Yeah.
So if the smallest was 508, it has to be 508 times 4. And then
Yeah.
if the largest was bigger than that, then it wouldn't work.
Yep.
Okay, so in this one, the assumptions, it has been met.
Yes. Yep.
There's only one option with have been met, so
Yeah.
perfect. And then they want to know if the mean is the same for all 3, and it is not. The degrees of freedom are 2, 51, and 53. Okay. And that F equals 16.07. That P is 0. Okay. What are you guys thinking for 15?
I think that we have sufficient evidence to claim that all 3 hot dog types have a different mean number of calories. And I say that because the p-value, because we're still just comparing the p-value to
The significance?
significance, aren't we? Is that what it was?
I think so. And then plus if you run the ANOVA test, you can see that the mean isn't the same. I'm wondering if that's what. Let's see.
Yeah. So we reject the null hypothesis since the p-value is less than the level of significance, which the null hypothesis was that they were the same, right? Oh, well, yeah, I
Yeah.
guess it has to be. It's always that for ANOVA.
Yeah.
Okay. Now we just have to do the same thing with the sodium levels.
I'm wondering if 15 is all 3 or if it's just one of them, or at least one of them. But we can try it out.
Let's see.
16's looking like the assumptions have been met.
Okay.
And again, that's the only option.
Yeah.
And then for 17, let's see here.
0.179.
Yeah, she took the words right out of my mouth.
Haha. And then the conclusion is that it's greater, so we do have sufficient evidence, and the means are different. Is that what you think?
I thought it was. Let's see here.
Yeah. I think it's that we have sufficient. We have sufficient evidence to claim that all 3 hot dog types have the same mean sodium levels?
See, because I would think so, but then if you look at the graph, are we supposed to look at those means? That variable 1 is 4.401 and variable 2 is 418. I mean, so I'm looking at that, they're not equal, but as far as it being greater than.
Right, but I think that we're not just looking at the means, but comparing the p-value still to the level of significance.
Okay, then I'd say it's the same, that you're right.
Yeah, because I think since the p-value is greater than the level of significance, right? I don't know.
Yeah. I'm submitting, so I'll let you guys know in a second here.
All right.
Dun, 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 dun. Come on. Okay, question 18 is wrong.
Oh.
Question
Oh.
15 is wrong.
Oh, no.
It's those 2 questions. They're the same one. So we're not picking up on something. Maybe we need to look right in the book.
Yeah.
Common sense ain't doing it.
Okay, that's loud.
What? Sorry. Oh, there it is.
Corey, I think you might be right in that it's for the one we have sufficient evidence to claim that at least one of the hot dog types has a different mean number.
Did you find that in step 5? That's what I'm looking at in the reading.
Yeah,
right now.
well, right above where it says 5 worked example soccer shoes. Or yeah, I guess it's step 5. Yep.
Yeah, and plus, if you think about it, if we're doing the alternative hypothesis, that's what it is. It's not that they're all different, but that one is.
Right.
Yeah. So,
One
but then
is.
on 18, I thought it was the other way around. If it was greater than, let's see here. Let me get on the right page. So it was lower that we rejected the null. So this one, I would think that we don't have enough evidence. I think that's what 18 is that we don't have enough evidence to reject it.
What's the null hypothesis in this situation, anyways?
The null
It would
hypothesis
be
is
that they're
always
the
that they're all
same.
equal.
Yeah, it would be that they're the same. So in this situation, what's the verb? How do you say it? If you don't reject, you fail to reject.
Fail to reject, or we reject.
We fail to reject, right?
Yeah.
And if we fail to reject, then we do not have sufficient evidence to reject the claim that all 3 hot dog types have the same mean sodium levels.
I'm going to try it.
Okay.
So
what are you putting for 18?
Do not have, yeah, that's what it was.
Is that what it is?
We do not have, Yeah, we don't have sufficient.
And for 15, did you get it right with the 1?
Let's see here. Yeah, I think that's, yep. And just one of them, at least one on 15.
Okay.
Sweet.
Nice.
Awesome. Sorry I misled you.
Oh, that's
Don't
totally
listen
fine.
to me ever again.
It's all your fault.
All right. Well, Andy, if you could post that one, we'll all make a comment on it. Tell you thanks.
Yeah, Andy, are you recording this?
Yeah, I am. Wait, no, I didn't hit the button. Just kidding.
And then Thursday.
Yeah, what time do you guys want to meet Thursday?
Let's see.
It,
Oh,
it
you know
would
what?
it would have to be late for me because I'm doing this same stupid schedule all week.
Okay.
I think I'm working another 12-hour on Thursday, so it'd probably be about 9:15-ish at the earliest.
Okay. So then, since it's the review one, let's all make sure to do the first try by ourselves, like he suggests.
Yeah, and
because
then
it's gonna be a long one, and I don't want us to have to get on at like 9:30 and then be on to like 11, especially with Crystal's timing.
We can just see if anybody has any questions, basically, about them.
Yeah, any ones we missed, we can just go over.
Yeah, that works.
That's cool.
Okay, and then really quick, the last question, the answer was they have not been met. And it's not.
You mean question 18?
Yeah.
It's we do not have sufficient evidence to reject the claim. That all 3 hot dog types have the same mean sodium levels.
Okay.
Yeah, I think it was the only option that said we do not have sufficient.
Yep.
Perfect. Okay, sounds good. So 9:30 again Thursday.
Yeah.
Yep. Cool.
Sounds good, guys.
Awesome. Thanks guys.
Yeah.
All right.